This is Deep Learning Lesson 6, Autoencoders. For this ICP, we are provided with a source code. The first task is to add one more hidden layer to auto-generated, which is given in the source code. Now we will see the code. I have used the Google Colabs for coding. Here I have imported all the necessary packages, Keras layers and Keras models. I am giving the size of the encoding dimensions as 32. As I am giving the encoding dimension as 32, the input image input is given as 784, which is 32 into 32. Here we are representing the dense layer with the encoding dimension, this is the encoding representation of the input image, which we have read here. After encoded, we need to decode. This encoded is passed to the decode function of the dense layer with the activation function sigmoid by passing the encoding dimensions as 784. Here we are creating the model with the input by passing the input and the decoded message of auto encoder, and we are compiling the model here by using the optimizer delta and passing the loss function and here I am loading the data which is which is provided by the Keras datasets. Here I am splitting the dataset. I am training it by using fit. Here is the accuracy values for the trained data. I am predicting on the test data by passing it to the model autoencoder. By giving the random image of in the text of 50, we are just plotting the image. This is the input image and this is the predicted image, reconstructed image, the prediction 50. The prediction is almost same. Now we will see the second task. We have seen this test data and also visualize the same data before reconstructing using MATLAB. Repeat the question 2 on denoising the autoencoder. Till here, now I am adding one more layer to auto. See, to the input layer, here I am adding the one more hidden layer by passing the 512 neurons and the activation function as relu, and after this I have encoded. Once we have done the encoded by passing the hidden layer, we need to apply the decoding on the encoded part with the activation function, and we can apply test data on decoded by passing the input, and we are compiling the model here and training the data as discussed in the start of the program, and predicting the text here. This is the input image and this is the predict image, and the next task is to repeat the question 2 on denoising auto encoder. For the denoising, the code is already provided in the source code. This is the noise factor we have added of 0.5, and we have added the noise and scaling it, and we are training the model autoencoder. And before applying the noise data, this is the output image, and after applying the noise data, it is scattered. Predict to the test data input after the noise and predicted. For the history object, we have to plot the accuracy and loss. Here we have predicted and reconstructed the image by removing the noise. Here I have plotted the graph for accuracy. Thank you.